Good day, everybody. How are you all doing? Hope you are doing great today. The last time I talked to you guys, I told that it was cloudy outside, no sun, but today it is beautiful outside. All the rain has moved away, so I'm happy. Okay. So let me tell you a joke about statisticians. Why are the statisticians all, or why is a statistician always in trouble with the law? Because he's always caught conducting random samples. Okay, so I will stop today and let's get down to the nitsy gritty. So I'll share my computer screen with you. Hey folks, today we are going to talk about Chbyshevs theorem. You may have heard about this before, so I just wanted to make sure that you are aware of what the Chbyshevs theorem is all about. Now, the other thing that I spoke last time was empirical rule that applies to bell-shaped or normal probability distribution, like an inverted U, whereas Chebyshev applies to any kind of probability distribution. For example, so let's talk about a uniform probability distribution. So this is an uniform probability distribution. Let me erase that and make a better diagram. Let's first draw the probability axis. This is my probability axis, and these as the horizontal axis, that's the vertical axis, which is the probability axis, and these are values of random variable. Random variables, any variable we are talking about. So I'll give you an example of a uniform probability distribution in a minute. So as I told you, this vertical axis is where we are charting a probability or plotting probability or relative frequency. So we are going to do an uniform probability distribution today. The name uniform is significant. Okay, probability distribution. Probability distribution. Probability distribution. So it is a probability distribution because we are plotting or charting probability on the vertical axis or relative frequency on the vertical axis, and the value of the random variable, what we are studying, is on the horizontal axis. So uniform probability distribution, as the name implies, will have a same relative frequency or same probability value within certain interval. So basically it will be a rectangle. Let me draw that better. Okay. And this. Okay. So notice between A, the value of the random variable on the left-hand side, to B, value of the random variable on the right-hand side, the probability is constant. This is your probability. This is constant. This vertical axis is your probability, remember? That is constant. So that is why this is called a uniform probability distribution. That is between the values of the random variable between A and B, relative frequency or probability remains constant. What is an example of that, you may ask me? Well, an example of that is, think of you going to a traffic signal and it has turned red, and that traffic signal will remain red, say for 30 seconds. Okay, so between A and B is the interval of 30 seconds, and the probability of the traffic signal being red at that interval or at that traffic signal is constant. It is 1 over 30. Okay, because it remains, because why it is 1 over 30, let me explain it to you. Let me select, let me show you. I told you that the traffic signal has turned red for 30 seconds, which I indicate by S, which is the distance between A and B. So the interval, the width of the interval A and B, we are measuring the time, amount of time for which the traffic signal remains red, which is 30 S, means 30 seconds. So let me read. So traffic signal remains red for 30 seconds. Seconds. So distance AB is 30 seconds. 30 S, that's what I wrote. So S is for seconds. Okay. So the question is, what is the probability? Remember, area under a probability distribution. Probability distribution curve is always 1. Distribution curve is 1. So please do not quit right away, because you have stayed with me so long. So let's try to move further and extend your learning. I appreciate the fact that you're spending your time with me on this channel. So if you like this video, please give me a thumbs up. And if you like this video, share with your friends, and please subscribe to my channel by hitting the red subscribe button. So area under a probability distribution curve is always 1. Always 1. Because sum of the probabilities is 100%. So let's think about this rectangle, but let me change the color of the uh, let's make this contrasting. So let's use this color. Okay. And okay. So width, width of the rectangle, width of the probability distribution of the rectangle probability distribution 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 is 1. Is AB, okay, is equal to 30 seconds. We already talked 30. Okay. So the uniform probability, so this is the uniform probability distribution. Uniform probability distribution. And I explained to you why it is uniform, because whenever you reach the traffic signal, it will remain, and it is red, it will remain so for 30 seconds. So what is the height of this probability distribution? So the height, so get my pen over here. So height of the rectangular probability distribution or uniform probability distribution, if it, let's say it is H, rectangular probability distribution is same as the uniform probability distribution. Uniform probability distribution. And I told you the probability is constant irrespective of the time between 0 and 30 seconds you reach the traffic signal. Uniform probability. Okay, so let's call it the height is, let's call it h. And that I will show in the diagram. This is the height I'm talking about. This height is h, this height. From here to here. Also notice from A to B, I already explained it remains red for 30 seconds. Okay, so the width of AB is 30 seconds. Now let's find the area of the uniform probability distribution, which should be 1 uniform, or in this case rectangular probability distribution. Uniform rectangular probability distribution is width times height is equal to width multiply by height. So that means height. So that will be equal to, my width is 30 and my height is h. But we know area. So if I move this a little bit, total area, total area, total area under the uniform probability distribution is 1. Probability distribution is 1. We all know that because the sum of the probabilities is 1. That means, or in other words, or total area, or 30 times h is equal to 1. Sum of the probabilities is equal to 1. Total area under the probability distribution curve, probability density curve is 1. Now we will divide by 30 on both sides. So what do we get? We get 30 and 30 will cancel on the left hand side, and we will get h is equal to 1 over 30. But what is h? Is the uniform probability value. So all points between A and a B, value between A and a B. Hence, this is called a uniform probability distribution. Uniform probability distribution because probability of all values between A and a B, of all values between A and a B is constant. Constant at 1 over 30 seconds. So whenever you reach the traffic light between 0 and 30 seconds, the probability of the traffic light remaining red is 1 over 30. Hence, it is called a uniform probability distribution. Thanks for taking the time to watch my video. If you like this video, thumbs up and let me know in the comments box. Where are you watching from? Please let me know. I always want to know where are my subscribers coming from. I really appreciate that information. Okay. And also, if you like this video, please click on thumbs up. I really appreciate that. And Please share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner, and also please click on the bell because that will notify you every time I upload a new video. And please do not forget to watch my video tomorrow when I'll be talking about an application of uniform probability distribution, and it is called Chbyshevs theorem. Now take care, have a nice day, and see you tomorrow.